Good morning, students. Today we are going to discuss Monte Carlo simulation technique. This is a very famous and important technique of decision science. This technique is used to simulate and forecast demand for the future on the basis of available data, that is historical and present data, and probabilities of getting that much of result. On this basis we can simulate the demand or we can forecast the future. This is a technique where we develop real systems, and on the basis of real system we do experiments on the sample, and we will get our expected result. So Monte Carlo simulation technique is one of the famous technique of statistical data analysis. I have shared an Excel sheet with all of you. Through this numerical, we are going to learn how to solve and how to get expected result and how to forecast data if the historical and the present data is available with us. So on your screen now, there is a problem statement given for a bakery, and that is a bakery having following stock of cakes, daily demand pattern for the cakes with associated probabilities as given. They have provided you daily demand of cakes and probabilities for that particular number of cakes demand they have provided you. So on your screen, daily demand is given like 0, 10, 20, 30, 40, and 50. And probabilities are given like 0 0.01, 0 0.2, 0 0.15, 0 0.5, 0 0.12, and 0 0.02. These are the probabilities are given. On the basis of probabilities provided, we can simulate the demand for next some days, whatever we want. Okay, so here in simulation technique, one more important thing is on the basis of random numbers and random number intervals, we simulate the demand for the future. In statistics, you know that always when it comes to random number and forecasting, we use a statistical table for random numbers, which is there already. When your numbers are given from 0 to 99. That means first 100 numbers. We are counting 0 in a number. So 0 to 99 will be the first 100 number. If your intervals are between 0 to 99, it means the first 100 numbers you are going to consider. And if it is 100 to 999, it means what? You are considering first 0 to 999 means first 1000 numbers. So as per the data given, we can use our random numbers from random number intervals. Okay, so there is a problem statement given on bakery, and the stock of cakes is given and probabilities are also given. So on your screen probabilities are given. So what you need to check first, the total. Always the total of all these probabilities, that is fifth row, probabilities are given here. So total of all these probabilities always must be equal to 1. So total of this fifth column sum is equal to 1, because of probabilities are always between, probability is never negative. It is always lie between 0 to 1. Probability is never more than 1. 1, if you are getting answer, your probability is equal to 1. That means there are 100% chances of getting success. Probability is actually what? Chances of getting success on an event. And if you have answer as a 1, then it is like you will get success of on that particular trial or on that experiment, a sure shot. So probability is always extreme limits for the probabilities are 0 to 1. It is never negative and never more than 1. So here this sum must be equal to 1 always. You need to check that before we start preparing solution for the problem. Okay, so they have provided you some more information, like use the following sequence of 10 random numbers. 10 random numbers are given, and you need to simulate the demand for next 10 days and average demand per day. They are asking you to calculate demand for the next 10 days on the basis of available data, and they're asking you to calculate average demand per day also. So now come to solution part of it. First of all, in this exam, in this numerical, we need to understand there are random numbers are given. We need to use random number intervals. There are probabilities are given. There are daily demands are given, and they have asked us to simulate demand for next 10 days. Okay, so these are the things we need to understand first. Now the process or technique to simulate demand for future next 10 days means it's a future. That is why this technique is called as what, it is a forecasting technique used in decision science. Okay, on the basis of this expected result, we can say management managers, they can take decision. This technique help decision makers to take a right decision about their variables, okay, which are there in the all the type of organizations. Now, come to the solution part of it. Uh, First of all, what we need to do, daily demands are given. It is already given in your example, that is 0, 10, 20, 30, 40, and 50. It means there is a probability 0.01 having demand 0 on the particular day. Probability is 0.2 having demand for the particular product is 10. So likewise, this data is given. If someone asks you what is the probability of having demand 50, so the probability is 0.02, which is given in the last column. So daily demand and their probabilities are provided. Now, for the solution part, we need to calculate cumulative probabilities. Okay, solution for the solution part, we calculate cumulative probability by adding like 0.01 plus 0.02. So first answer will be 0.01 as it is. Then the second cumulative probability will be 0.01 plus 0.02. That would be 0.21. So likewise, we calculate probabilities for having daily demand 10. The cumulative probability will be 0.21. Likewise, for having a 20 daily demand, that cumulative probability is equal to 0.36, then 0.86, 0.91, and your cumulative probability for the last item must be 1. Then only you can say that your cumulative calculations of cumulative probabilities are, you are in the right direction and it is correct. If the last answer, the last probability is equal to 1, then only you can say that. After that, after calculating cumulative probabilities, we need to write down, actually, it is already given. We need to write down random numbers, intervals. Okay, random number interval. It is given in the column E. Okay, so random number intervals. So first, the demand. Okay, random number intervals are already, it is there. So random number intervals are 0, first number actually, 0 to, and 0 to 0, it means it is 0. Then second random number interval is 1 to 20. Then third one is 21 to 35. Then 36 to 85. Then 86 to 96, then 98 to 99. Now, how we have calculated this random number interval? You have with you your column number D, that is your cumulative probabilities. As all the random numbers are given in column G is between 0 to 99. So first 100 number intervals will be applicable here. So you need to multiply. We need to multiply. Here I'm going to do the calculation. 0.01 multiplied by 100. You need to do this. Your answer will be 1. So because of your random numbers are 0 to 99 first 100 numbers. That is why you are going to multiply this cumulative probability by 100. Then you will get your random number interval. Your random number interval for first demand having 0 demand is 1. 1 means your first random number, and first random number from the number line is equal to 0. That is why the interval is 0 here in column E12. Then for second cumulative probability is 0.21. Okay, multiplied by 100, your answer will be, just a minute, I'm showing this calculation here on your screen on this Excel sheet. You can here you can see that 0.21 multiplied by 100, that will be your answer. So here answer will be 21. It means what? Your first 21 numbers, that interval will be 0 to 20, because of we are considering 0. So 0 to 20 will be your second random number interval. But in the first interval, already you have covered 0. So second random number interval will be 1 to 20. Likewise, if you multiplied 0.36 by 100, you will get answer 36. It means the first 36 random number. So 0 to 35 will be your 36 random numbers. First 36 random numbers will lie between 0 to 35. That is why your random number interval for the third daily demand having 20 and probability 0.15 is equal to 21 to 35. Likewise, we have calculated random number intervals for other demands also. Now, in your example, it is asked you for the simulate the demand for next 10 days. Okay, here it is written. You need to calculate, you need to simulate demand for next 10 days. Now we have random number with us, cumulative probability is with us, and we know that for the next 10 days, we need to simulate the demand. So next 10 days, in the next column, in column F, we have written down 10 days, next 10 days. So day 1, 2, 3 up to 10. Now, random numbers are also given in your example. Random numbers are given in the example. We just need to write here are random numbers. Random numbers are provided in sequence. In that sequence only, we need to write it down. While writing random numbers, we know there is no need to follow any sequence of ascending and descending order as it is. However, and whatever they have provided you random numbers, that only you need to write down. So 25, 39, 65, 76, 12, 5, 73, 89, and 49. These are the random numbers provided to you. Now, now here we need to calculate random number intervals on the basis of random numbers provided. Okay, now here, look at your screen. Here we are going to calculate random number intervals. Now random number 25. Okay, so this random number 25 will come in random number interval. Which one? 21 to 35. So just we need to write down here random number interval for that particular number. 39 is the random number provided. 39 will be there in first 36 to 85 numbers. 65 will be there into the same interval. Again, 76 also will be there from the same interval. 12 is the random number provided. That will come under the random number interval between 1 to 20. Again, 5 will come under the same interval. Then 73 is a random number provided you. So 73 will come under 36 to 85. Then 89 will be there in 86 to 97. Then 19, again, 19 will be come under 1 to 20. So this is the way we can calculate our random number intervals. So random number intervals, if you have done with that, then easily you can simulate the demand for the future. It is not a difficult task actually to simulate demand if you are able to find out your random number intervals. Now come to your calculation of a daily demand, how we can simulate daily demand. So your random number interval is 21 to 35 here. Okay. So when your random number interval is 21 to 35, then daily demand in that particular case will be, so here 36 to 85, 21 to 35 in your column number E. Okay. In your column number E, it is given that when your random number interval is between 21 to 35, in that case, your daily demand is 20. Okay. Here, I have marked this 20. So when your random number is lie between 21 to 35, then daily demand is equal to 20, having probability 0.15. So here, daily demand, if your random number is between 21 to 35, daily demand will be 20. If your random number is between 36 to 85, then daily demand will be 30. I have again highlighted this daily demand. So here, if it is 36 to 85, then your daily demand will be 30. Same is applicable for the same random number intervals. We need to write down daily demand. When random number interval is between 1 to 20, then daily demand is 10. It is given here. It is given here, 10. Okay, again, I have highlighted the same number. If it is 1 to 20, then daily demand is 10. If your random number is lie between 86 to 97, then the daily demand is equal to 40. Again, I have highlighted this 40 in column number B. Then 1 to 20, for 1 to 20, it is 10. And for 36 to 85, okay, I hope you are getting me. So this is your daily demand for the random number intervals given. They have asked you to simulate demand for the next 10 days. So here we have simulated demand for the next 10 days. They have asked you to calculate one more thing, that is average daily demand, average demand per day. So how we calculate generally average? So we need to add this demand for the next 10 days. We need to add this, and then I am applying a formula for the auto sum here. So we'll be having this. Just a minute. So total of this column number I is equal to 240. So the total is equal to 240. We can calculate here average demand per day. So average demand per day is equal to 240, as it is a total demand divided by number of days, because of for 10 days we have simulated demand. So average demand per day is equal to 24. So this is how we can simulate a demand for the future, and we can calculate average daily demand for the cake, because of it is given in the example that you need to calculate average demand. So 24 is the answer. I hope you all are getting me. If you have any queries on simulation problems, on Markov chain simulation, you can contact me. You can send an email, or you can post your queries on the chat box. Thank you so much. Have a nice time.